Okay, now with these basic logic gates, you can build up any circuit, actually. Any logical circuit, you can use these as building blocks, and you put these pieces together, you can build up a very elaborate circuit. In fact, let's see. So we're going to do some of that. If you want to turn to 13.3, so I'll bring it up here. So I want you guys to try and do this. Okay, so now the way that this activity works is that we're going to have 13 LEDs on our screen, okay? And you want to form an 8 image like this. So the idea here is this is going to be like an LED counter display or something.
You want us to do that?
Yep. So put that into the sandbox. You want to load up 13 LEDs. So you only need one power supply. You just have 13 LEDs.
Okay, so it's a connection.
And then, then the question is, you want these lights to flash in a certain way. And so what this activity is doing is, you want to wire these lights such that it follows, it satisfies the following relationships. So L2 and L8, which would be that light bulb and that light bulb, that is going to be the knot of X. Right, so you're going to have two toggles, X and Y, and now they're going to control the behavior of all 13 lights. And here's the rules of how they behave. So I'll walk you through the first one. Let me bring up 13 lights on mine. Yeah, I guess doing the full truth table of the other gates. Yeah, fair enough. But it is somewhat satisfying because you see this is. I mean, if you look at old scoreboards, they're designed exactly like this. Because now, basically, using the lights, you can put up any number, 0 through 9. So it has a very kind of practical feel to it. All right. So,
Is that XOR supposed to be there?
no, I'll get the XOR out of the way.
Okay.
All right. So the first line here is that the prescription is that L2 and L8 should both be the knot of X. Okay? And the way that I'm going to think of this is that this is toggle X and that's toggle Y. Okay? So I'm going to use the labeling here. So according to the labeling, this is L2 and this is L8. Right? So we want to hook these up to the knot of X. So the way we do this is we pull out our NOT gate, and now we just wire it, like here's, like that.
Okay.
Oh, I see. Okay.
I'm kidding, the counting 2 and 8. There's a 2 and 2.
Yeah, use your. This is like the labels there. See?
Oh, because I
Yeah.
was like, what?
Yeah, I know. How did I know, right?
I was trying to figure out.
Yeah. Don't count them. Just use the chart in figure 13.2.
Okay,
Yeah.
so the knot is 2.
So the knot can make any color
Yeah, just depends. It all depends on how it's wired. Yeah, sure. Right, you can wire it.
I'm just playing around.
Yeah,
with
yeah,
this.
no.
This is all new to me, so.
Right. But that's right. I mean, it all depends on how you wire it. Okay, so now that we have that one done, now the next line is a bit of a bigger set of wires.
12 all equal to not of X or Y.
Mm-hmm. So let's talk about how to interpret this. Sort of. Yeah, it goes clockwise, and then 13's in the middle. So starting at the upper left, you're going clockwise. Yeah, 13. Yeah, exactly. Okay, so the second set of wiring, it says that you're taking all of those L1, L3, L5, L7, and you're doing not X or Y. Okay, so let's think about what this means. Okay, not X or Y. Okay, so I'm going to draw out what it would look like. So if here's your X toggle, and here's your Y toggle, the way to read this is that we first do a not X, then we take that and we OR that with Y. Okay, so the first thing we need to do is we need to take our X and we put it through a NOT gate, which looks like that. And now we want to OR that with Y. And then that's how it looks. Oops, I should probably curl this a little better. Okay. So is it clear? Everyone kind of understand how this not X or Y looks like this in the circuit form? You have your XY, you send the X into not, and so then what's going into your OR is the not X or Y, and that's what's coming out. Okay, so then the activity then is you want to hook this output up to L1, L3, L5, L7, L9, all of those, right? Because this output is going to be connected to all of those bulbs. So Yes.
Yeah, okay.
Yeah. That's right.
Oh, not X. Okay, I had not X or Y.
You guys getting it?
So my not is wrong. My, yeah, my not wrong.
Yeah, looks good. Okay, and then the third part is, yeah, holding.
Sorry.
Sorry.
So on the toggle for the next one, we're just connecting to the 4 and the 6 from the second toggle here.
Yep, exactly. Yeah. So now we can do the next one. We can connect 4 and 6. And then the last one is the ENOR, or the exclusive NOR. So that one is, that's XNOR on the, in terms of the gate.
Okay, so it has to be connected to,
X and Y like that.
okay, so X and Y goes, okay, got it.
Yeah.
So we have to put the new X.
All right. Okay, so let's write down what we get.
Yeah, oh, so my stuff came on before I finished.
That's all right. That's all right.
Now it may negate and turn something off. Okay, so that was supposed to go just to 13?
Just a 13.
Is that the only one that didn't have something connected? I was looking at who. Yep, that was the one that was left by itself. Let's see if it turns some things off now. Whew.
Okay, so what do you read? What letters come out?
Oh my gosh. Okay, we supposed to click?
Yeah, so now let's interpret. So yep, so they're both off. What letter do you see? I heard an E. I think that's right. Now 0, 1. O. And then 1, 0. Okay. And then 1, 1. Okay, good. Does this make sense?
Yep.
Any questions?